So we just learned about using take latest versus take every versus take. Let's actually switch our take every call here over to using take latest, because in theory, we only want to issue this API call one time versus firing multiple that might resolve multiple times. If take latest ever fires multiple times, the last one is probably going to get the most up-to-date data from our database. So it's safe to say using take latest is the best option. Now, one thing that we're going to do next is we're actually going to create what's called a root saga. Just like a root reducer, we're going to make a root saga that issues and calls all of our other sagas. The reason for this is because inside of our saga middleware.run, if we wanted to run multiple sagas or have our saga middleware listening for multiple sagas, we have to call .run individually on every single saga that we want to be aware of. So instead what we'll do is we will run all of them at once the application starts up in one large saga. So in order for us to do that, we are going to make a root saga .js, and inside we will import this new effect called all and the call effect that we've used before. Now, what we're going to export out is going to be a function that is a generator function called root saga. And what it does is it yields to this all call, which gets an array of generators that we invoke. Now, the saga that we do want to run first will be our fetch collection start from our shop sagas. And then inside of here, we can either invoke it ourselves manually like so, or we can just run call like this. Again, it's preference, but most people prefer to use the call keyword here just because of practices. And we import this one saga in to our reducer. So instead of running this one, as we did here, we instead now just import in our root saga from root saga. And now we'll see our code works the same, except whenever we add a new saga that we want to listen for, we just put it into this array, right, and call that saga, just like we did with root reducers and our reducers. Now, let's actually take a look at all. What is it that all does? Well, all takes an array of sagas. If we wanted to, say, render 3 different sagas, imagine we had 3 sagas. Typically what we would have to do is we would do this multiple times, right? We would yield these different sagas, right? Imagine there are 3 different sagas. We would have to write our code like this. But this code is not running these 3 individual sagas concurrently. This next yield is actually waiting for this yield and this saga to resolve with some value, or at least when that saga leaves at some point, which gives control back to our root saga so that it can continue on to executing the next saga. We don't want that. We want all our code to pretty much initialize as soon as possible side by side. And that's what all allows us to do. By using the yield all call, we're able to actually call any number of sagas inside of this array and initialize them all on separate task streams, which is exactly as we learned with take every what we want to do. We want to be able to have individual tasks that only care about the saga that they're looking for, right? And we want to initialize them all at once whenever possible. And that's why we use the all effect. But with this, we now have set up this pattern that allows us to add all our sagas to this root saga and not have to worry about adding more and more saga middleware.run calls.